Okay, so before we talk about what SQL is, let's talk about why we should learn SQL and why it's important. So in the 21st century, data is being collected all the time to like help organizations optimize their work. And whether we're aware of it or not, data has been collected and stored on all of us. So like everything from like the music you listen to like the movies you watch, to what you buy at the store, to like your internet searches. And yeah, I can go on and on. And outside of the business world, data is being collected for like important climate change research, healthcare analysis, and trying to solve the universe's greatest mysteries. So you guys understand that data is key. So everyone's collecting it all the time, and it's like one of those things that the people who can use and interact with it and can use it to think critically and provide insights of it to make better decisions are going to be the people who can contribute to like shaping the world we live in. So yeah, these people are like data analysts and data scientists and data engineers. So to be good at these fields, you need to know how to retrieve and work with data. And to do that, you need to be well versed in SQL, which is a standard language for communicating with databases. So the purpose of this workshop is to give you a primer in the fundamentals of SQL and working with data so you can begin analyzing it for analytical purposes. Next slide, please. Okay, so what is SQL? So let's begin with the acronym SQL. So it stands for a structured query language. So this is the standard language for many relational database management systems and data manipulation. So SQL is used to query, update, insert, or modify data. And at a very basic level, it's just a method for communicating between you and the database. So one of the great things about SQL is that it's made up of statements which are descriptive words. So this basically means that like many of the commands used in SQL are fairly easy to interpret as compared to many other computer like coding languages. And this makes SQL as a language easy to understand and learn. But it's also important to understand that it's a non-procedural language, which means that you won't be able to write complete applications with it. But you can do this, but what we can do is like interact and communicate with this data and get the data that you want, which makes it like a relatively simple but like powerful language, right? So when you think about SQL, all you need to think about is data. SQL is all about data, and it's used for three main things. So first, it's used to retrieve and read data. So data is often stored in databases, and if you want to retrieve it or read it, you need to use SQL. And SQL is also used as a way to like write data in a database. So let's say you have an existing database and you want to add things to it, you can use SQL for that. And finally, it's used to like update and insert new data. So you can modify the data and insert new data. So you guys understand that like this is why SQL is important. So here I've listed like a few popular database management systems, some of which are PostgreSQL, which we'll be using today, SQLite, MySQL, Oracle SQL Developer. And yeah, these are just like different database management systems that you can use SQL with to access data. And yeah, now I'll pass it off to Adrian. It's recording.
All right, so let's move on to the next slide. So some background, some database basics. So what is a database really? Well, it's just a container to store organized data. So you can think of it as like a set of files, or maybe the database is a filing cabinet. So databases are classified based on what they have inside their content, whether that might be text, numeric, images, or something like that. Or they could be classified based on their organization. So they might be relational, like what SQL works with, or they could be non-relational, distributed, object-oriented. And now DBMS stands for the Database Management System or software, and that is used to create and manipulate the database. So we're looking at relational databases today, and these are tables of rows and columns that are linked. So this allows for complicated queries, and it's pretty suitable for transactions and sales. One advantage of this is that it can reduce redundancy. So you can filter out things that aren't unique, data points that aren't unique. a disadvantage of the system is that it gets more complex as the size gets bigger. So in comparison to a non-relational database that might not be as well organized, right? These relational databases can get kind of complex as for really large sets of data. And because these are so structured, they're also less flexible. All right, so looking at tables. These are identified by unique names, for example, customers. And they have characteristics and properties which define the data storage. These might be like what data type, how the data is named, what kind of data is involved, right? Like for customers, it might be like the first name, last name, where they live. And the columns of a table are the attributes. Each of these columns have a specific data type associated with them. So like in the case of customers, that could be age, or it could be like birthday, as you can see over on the table here. And each row is called a record. So that is all information associated with, like in the custom, again, back to the customer's example, all the information associated with a single person. So we can see over here, like Barbara, right? Her first name, last name, when she was born, her phone number, such and so on. And now all tables will have a primary key. So this is kind of like a license plate. It's going to be unique, and it identifies every row in the table, like license plate would identify your car. So you can't have a null value for this. So there has to be every row in the table has to have a primary key. And these are never going to be modified, or they're never going to be reused after a row is deleted, just to prevent maybe some sort of coding problems if you're referencing a previous one. So as you can see over here, what we did with the customer ID in this table is we just did in ascending order. So that's an easy way to make sure that there are no repeats. Now for foreign keys. So this is how we link two different tables. So they reference the primary key of a different table. So now if we're looking over here, right? The primary key of the customers table is going to be the customer ID. But in the tickets table, we also want to include the customer ID, because maybe this specific person bought a ticket, right? So you can see over here, you have an arrow drawn from the foreign key here in the tickets table to the primary key that it's referencing in the customers table. And for foreign keys, unlike with primary keys, you can have repeats. So for example, one customer might have bought 2 tickets. And the customer ID in the tickets table has to exist in the customers table. Otherwise, that just wouldn't make sense. You'd be referencing a customer that doesn't exist, right? Now let's get into the actual SQL statements. So we're going to be retrieving some data. So some basic formatting things. So these aren't case sensitive, but the names of like the tables, columns, and values, they might be depending on the system. You want to separate your statements by semicolons. And when you retrieve the data is going to be unformatted. Common practice for when you're typing is to have uppercase keywords and lowercase column and table names. That's just to easily distinguish between the keywords and the column and table names. That's not like a absolutely mandatory thing, but it's good practice. And you can also use white space because the semicolon means the end of the statement, right? You can use white space to make it more readable for you. All right, so this is a basic statement. This is good. The select keyword specifies which columns you're going to retrieve. So in this case, it's customer ID and customer postal code from the customers table. So the from keyword references the table. As you can see, this is what comments look like. This one actually applies to multi-line, and this one's a single line. So what do you guys think we might use to retrieve all the columns from a table? You can type it in the chat. Could be a keyword or something. All right, got it in one. Yeah, That asterisk means all columns. Great job, Alec. So this means select all columns from customers. Now, what do you think we might use to pull only unique values. We only want the unique data. We don't want any repeats. Any guesses? Type it in the chat. Yep. Yeah, so that's going to be distinct. So select distinct customer first name, customer last name. So this applies to both of these columns. It's going to allow John Doe and John Smith, for example, right? Even though they have the same first name. Now, if we didn't have customer last name here, if it just said select distinct customer first name, only one John would show up. And you can see an example of this later in the demo. All right, now for sorting. So the order by keyword allows us to sort. So that's automatically going to be in descending order. And in ascending order. And if you want to make it descending, you can add this keyword at the end of the column. So order by must be the last clause in this setup. All right, now for filtering. So the where keyword is what we use for filtering. So you can set some sort of condition. Like if you don't want people in this zip code, right? So you can say where customer postal code does not equal this. So you can look at, there's all of these symbols here that apply to, less than, greater than, something like that. So if maybe you would want to retrieve people who are only younger than 18 in your customers. All right, so a couple keywords when you're using filtering, right? You can use and, or not. So these are pretty self-explanatory. And is when you want multiple conditions to be true. So you want the customer postal code isn't 0727 and the city is New Brunswick, for example. Or is when you only need one of them to be true, and not is when you want the opposite of what condition you set. So it's kind of the same idea as the exclamation mark over there. All right, now joins. So an inner join is only going to pull the intersection of two tables. So it's just going to pull the matching values, as you can see over here. And now this is a code example. We're going to see an example of this in the demo. So if you're a little bit confused on how this would actually show up once you put in the query, just sit tight and you'll get to see it. Now for outer joins, there are three types. So you can have a full outer join, which will pull everything. A left outer join will only pull the left table. So what's considered the left table is going to be the first one you put. For example, the one that's right after the from keyword over here. And now the right outer join is going to pull everything from the right side. So that would be the second table. The reason why you don't technically need the right outer join is because you could just swap the positions of the table names, right? So you could just use left outer join and then swap the positions of the table names if you wanted. All right, the last type of join here is a self join. So it's like the table is duplicated and then you patch it back together with itself. So because this is the same table that you're using, right, you have to name them during the query. So for example, over here, table name A, table name B. These two are going to be the same. So it could be from customers A, customers B. That way you can distinguish between the two. All right, now let's get into the demo. I'll pass it off to Jay.
All right, thank you, Adrian. All right. Is my screen sharing?
Yeah, we can see it.
All right, cool. So you're gonna hop onto PG Admin if you downloaded it from that link that Bhakti sent in the chat. And once you open it up, all of this should be closed. So you're just gonna click the down arrow on servers, PostgreSQL should pop up, and then there's gonna be a databases. You click on databases, right click on it, and then click database. You can name it whatever you want. We're gonna name it bits for now. Click save and you'll have this little X over here. So you're just gonna open it up and then everything's gonna format out. And then you're gonna right click again and click query tool. So the query tool is basically where you put all your commands that you want. And right now we don't have any tables inside this database. So we're gonna have to create a table first. The code to create a table is also inside the link for where the download was too. And we did that because it's kind of long. So I'm just gonna explain it really quick. So to create a table, you say the first two keywords, create table, and then you follow it by the table name. Here we're naming it customers. And then every single column that you want in the table, you're gonna put the column name followed by the type of characters that's gonna be inside the column. So for example, customer ID, it's all gonna be integers. First name is gonna be a var, which is just various characters, and you specify how many numbers, how many letters will be inside the characters. We put 250 just for the sake of it. Obviously, nobody's name is gonna be 250 characters long. There's birthday, which is date format, and everything else is either var or int. And then to run this query, you just press this button over here on the top called execute. And right here on the bottom, you should get a message saying create table, query returned successfully. And now if we try to call that table, just use the command that we learned from before. And you could see that there's nothing in this table right now because we haven't really added any values into it. All you could see is the column head, the column titles. So now you could head back into that document and you'll see the where we actually start putting populating the table. So I'm going to enter that code right here. And this one's also really long, and I'll just give you how it works. So you type the words insert into the table name, which we said was customers, and then the keyword values followed by all of the records that you want to be inside the table, and it has to be in order of how the columns are separated. So for example, here, customer ID is 1, first name Barbara, last name McCaffrey. That's the birth date, phone number, street address, city, state, points, and the friend number. And then you do the same thing. You just press the execute button, and you'll see that the query returned successfully. So now we could start performing operations on the table. So first, we're going to just run the standard query, select all from customers, and we're just going to look at this table really quick. So you could see that there's 10 records. And out of all these records, there's one duplicate right here where the Clemmy's is first name between customer ID 5 and 10. And also we have two duplicates on states where 2 people are from California. So we'll just keep that in mind for now. So does anybody want to guess how we could pull up just the first name, last name, and birth date?
Feel free to unmute yourself or just like type it in the chat.
We're not going to use where yet, but that's a good guess. And yeah, Alec, that's the right answer. So we're going to do select, and anything that follows select, you could just remember as what's going to be returned onto the screen. So we said we want the first name, last name, and we want the birth date. So we just type the column names exactly how they're formatted. So select first name, last name, birth date, and we can't forget the from statement. So from customers. And we get exactly what we wanted. We just got the first name, last name, and birth date. all 10 records are in here, and there's none of the other columns are included. So now say that since we do have the two Clemmys as the first name, say we only want one record of Clemmy. In order for that to happen, we'd have to use the distinct keyword like we learned before. And following that distinct, we just write exactly what you want once again, which is first name, and then follow it by the table from table name. And now you could see that only 9 records are here, and there's only one Clemmy. The other Clemmy is not here anymore because we said the distinct statement, and we didn't want the other Clemmy to show up. So now, what would we type in if we want just a single record from each state, and we don't want any duplicates from state? You don't have to type it. You could just shout it out too if you want. Perfect. Good job, guys. It is select distinct state. And we're going to do that right now. And you could see once again that only 9 records are returned out of the 10 because there's one duplicate of California and it only shows up once. So good job, guys. Now we're going to go into sorting. So first, we're just going to pull up the table again so you could get a glance at it. And say right now, say for example that we wanted to get this same exact table with all the records, but we want, instead of the customer ID to be in order, we want the first name to be in order. Clearly you could see right now that it's out of order, like Amber's the 4th record, Barbara's the 1st, and so on. So in order to do that, you just leave the select all from customers, and then you start using the where statement. Not where statement, the order by statement. And then you, following the order by, you just type in the column name that you actually want to be ordered. And since we said first name, we're going to just call that. And now you can see that the customer ID is no longer in order, but you can see the first names are. So it goes A, B, C, all the way to R. And now say, for example, if you want to do city, we could also do that. And you can see right here, it's Arlington, Atlanta, all the way down to Walton. So now, does anybody want to guess how we could order it by first name, but rather than going alphabetically, we go backwards? Yep, DESC is correct. That stands for descending. Good job, Alec. So we're just gonna do that. We're gonna just keep that order by the column name, and we just follow it by the how we want it. And DESC is, oops. Sometimes I don't know why the format gets thrown off, so you just have to retype it. And there we go. Now Ramos the first name and Amber is the last name in the records. So now, say we want to order it by more than just one column. Like for example, right now we have it ordered by first name, but Clemmy Jones comes before Clemmy Betchley. And since we don't have any other first names being repeated, obviously it's going to look mainly the same. But what if we want Clemmy Betchley before we want Clemmy Jones? Because we want the last name to be ordered. Well, to do that, you just specify the order in which you want it to be ordered. So like first we want to go by first name. And then after the first name is alphabetically separated, if there is like name starting with the same letter, we want to go to the last name. So you just follow it right by the last name. And you can see right here now, Clemmy Betchley is ahead of Clemmy Jones because we specified that first we want to order it by first name and then we want to follow it up with the last name. All right, so now we're going to do filtering. And filtering is when you start using the where statements. So once again, we're just going to go look at the table. As it originally was. And so say, for example, we only want to gather people from California. We don't really want any of the other states like Virginia, Colorado, and whatsoever. So what you do is you keep that standard statement, select all from customers, and then you follow it by where, and then you specify the column name that you want to filter out. So state equals CA. And you could see here that only 2 records are returned because there was only 2 records that had California as their state. And so say, for example, we don't have select all, but we have from customers where state equals California. What do you guys think would happen if I did select first name from customers where state equals California? Like, what do you think will be returned to the screen? Raymond, that's a good guess, but that's not exactly true, and I'll show you why. And yeah, Thomas, you got it. So what even though we specified that we want the state to equal CA, since the state is not actually included inside of the query after the select statement, it's still going to filter out the statement, but I'm still going to filter it out by state. But that since we didn't include it in the select statement, it's not necessarily going to have to be there. See, as you can see, it's just Rommel and Clemmy. And we both know from the previous record that they are from California. But since we didn't specify that we want the state, it's only going to return the first name, even though they are both from California. So you could still filter out records without returning that actually the row that you want to, in the column that you want to filter on. And now if you go through the birth date, you could see that there's people born in the 80s, 70s, 60s even, and the 90s. So say you only want to return the records of people that are born between the 80s and 2000s, right? So you still use that where statement as before, but there's a little bit of a twist now. So you put the column name that you want, being birth date, and now you're going to introduce the keyword between. So what between does is you could use it only because since you could see right here that it's a date format. If it wasn't a date format, then like say example, you put it as a var, the computer wouldn't be able to read that it's a date. So it wouldn't really understand like the between statement. So we're going to put where the birth dates between 1980 January 1st and we'll do 2000 January 1st, 2000. So everybody from the 80s and 90s. And as you can see, there's 5 rows presented back to us. And all of these birthdays are from the 80s and 90s. So now say we want just the first name, last name, and the points from customers where their birthday is between the same date. What would you do? All right. Well, since it's actually not that difficult. Instead, we could leave everything the same. And like I said before, the only thing, if we just want to return the first name, last name, and point, we just have to specify that after the select statement. And it's the same exact names that we had before. It just happened to negate all the rest of the columns. And now, does anybody want to guess how we would query, how to get people, return the names of people who have more than 1,500 points? Oh, by the way, good job, Thomas. That was correct. Yeah, Hirsch, good job. So we just specify the where, and we'll set what we're looking for is points, right? So we're gonna specify that column name point, and we're gonna just use that operator, the more than, and just type in 1,500. And clearly you could see right here that none of these guys have under 1,500 points because we only wanted the people with more than 1,500 points. Now we're going to move over to and or not statements. So say we want a specific birth date and a specific birth date or live in California. So then we would type in select, and we just want we'll get everything. Select from the table name again. And now we're going to do where the birth date, and say we want the birth date 1985, February 7th. Or, so now we're going to specify, it's either they're going to have the birth date this, or they're going to live in California. So we specify that with the or statement. And you can see there's 3 people. So firstly, Freddie Bogey is born in 1985, February 7th, like we specified, but they're from Colorado. And the other 2 people, they don't have that same birthday as that we specified, but they happen to be from California. That's exactly what you wanted. And now what would you do if you want somebody with the name Ramala and is from the state California? Anybody want to guess? Good job, guys. Yeah, that's perfect. So yeah, you guys all got it right. Good job. So we're going to specify that we want the first name to be Ramala, and the state to be California. And you can see that there's only one person that that satisfies those attributes, and it's Ramala Rumgay. Her first name is Ramala, and she is from California. So now say, for example, we want everybody who's not named Ramala and who's not from California. What we would do is we just add this not, so it would be where not first name equals Ramala, and then we also do and not state equals California. And we get 9 records instead of the 10 because we know that Ramala is from California and her name's Ramala. But say, for example, we want to use the same exact record, but we don't want to use a not word for whatever reason. Well, you could do it because of the fact that we're specifying like equal statements inside the query. So instead of putting that not keyword, we're just going to do where first name, use that exclamation point equals, that stands for does not equal Ramala, and state does not equal California, and nothing changes because of the fact that that's virtually the same statement. But the thing about these using the does not equals and not statement interchangeably, it doesn't work all the time. So for example, if we were specifying a between birth date, we can't use the does not equals like the exclamation point and equal sign. So here we go. We're not birth date between these dates. So it finds everybody that's born before the 80s, right? And say we try to use the does not equal instead of the not, where the not is, and it just doesn't work because of the fact that we never had like an equal statement in here. It was just a between statement for these two dates. All right, so now we're going to go into joins, and this part gets a little bit more tricky, but it's still not too bad. And we are going to have to create a new table so that we could get this to work, because we're going to join these two tables. So this table is basically has all the same attributes. It just doesn't have a column with the friend, and it's shorter. So, and then we're going to do the insert statements. And these are all inside the doc, by the way, because I know it takes a lot of time to type these out. All right, so now we're just going to take a peek at that new table we created called customers 2. And there's 6 records, and all these names are similar to what they were before, but now we have a new name called April. So now say we want to do a join on where the same names occur across both tables, right? And from this join, we only want the customer ID, the first name, and the last name. So we specify exactly what rows we want, and we have to specify it with the table name dot followed by the column. So in the customers table, there was a customer ID, there was a first name and a last name. So we follow that customer's table name followed by the rows that we want. And similarly in customers 2, we also have a customer ID, first name and last name. So we'd have to specify that we want those from customer 2 by labeling the table as customers 2 and then following it by the columns that we want. And then we say from what table we want it, customers. And like we said before in the PowerPoint, the table following the from in joins is going to be considered the left table. And then after the from statement, you specify the join that you want, and we want an inner join right now because we want to match only the people that share the same first name. So inner join followed by the table name, and then you say the keyword on and specify what column you want you want the values to be equal on. So we're going to do customers dot first name equal to customers 2 dot. So what this will do is, this is basically read as that we're going to find exactly where the intersection of the two tables is based upon first name, and we specify that by following the on statement with the table name dot the column that we want it to match. Oops. First name, there we go. So here you can see that the first names are going to match up with the first names, and So all these three columns right here are from the left table, the customers table, and these three are from the customers to table. And it follows exactly in the order that we selected the columns that we wanted. So you can see that Clemmy matches Clemmy, and so on. But you can see that the customer IDs are not the same because in the records, we didn't make the customized ID the same for just to show that they might not be the same person. So does anybody want to guess how we would find the people from the same city on each table? I'll give a little bit of a hint because I know it's kind of hard. So from the select statement, we're just gonna put, instead of the customer ID, we're just gonna put city so that we know that, so we could see that they actually do share the same city. All right, well, it's actually not that complicated. Since we said we want to just share the same, oh, perfect, Thomas, good job. Exactly how you said it. Since we don't want it to match the first name anymore, but instead we want the city, we just get rid of that first name. Instead, we match it on city. And that's exactly what happens. Clearly, you can see the Chicago is matched with the Chicago, Nashville with Nashville, and so on. So now we're gonna move from an inner join into a full outer join. And we're gonna go back to that. Actually, this time we're just gonna show the first name and last name instead. And then we're gonna match it on first name again. So the difference with between the inner join and a full outer join is that in a full outer join, you're gonna even include the columns, the rows where there is no match. So you could clearly see right here, there's no Barbara, Ines, Freddie, Amber. None of them have a match on the second table because in that second table, those people don't exist. That first name does not exist. So there was no match, but it's still gonna put it there because we did the full outer join. And then it's followed by all of the columns that all the rows that match across the two tables on customers and customers too, because there is Elka on both tables, there's Levy on both tables, and so on. And then finally, right here, there's the null again because there's no April on that first table. April was a new record that we added when he made that second table. So like we said before, when you do a full outer join, there's different types of when you do an outer join, there's different types of outer joins. So there's also a left outer join. And what a left outer join does is it's only gonna get everything from the left table. And once again, remember the left table follows the customers, follows the from statement. So the left table is customers and the right table is customers too. And you could see it looks the same as before because we have all those items from the left table that don't have a match with the right table. But now there's no April at the bottom anymore from the right table because there is no match of April on customers table, the left table, but it is on the right table. But since we did a left outer join with customers as the left table, it's not going to include the right table anymore. And so now say that we want to find people with matching points across both tables. So we're going to do full outer join again. And we're just going to, instead of last name, we're just going to want to see the points. And you can see here again that this first 5 people, they don't have a point match on the right table because they're it clearly is null. And then here, like Elka and Clemmy have the same amount of points. Rama and Eileen have the same amount of points. And April has 24 points, but nobody has 24 points in the left table, so it's just null. So now say we want to find only the amount of people that are from the right table. Like we don't want to find any, if there's no matches on the left table, we don't want that. We don't want those records to show up. What would you do? I'll give you a hint. It has something to do with the join statement. All right. Well, it's actually not that difficult. So like I said, we don't want these statements. We don't want these rows from the left table, like all these nulls, but we do want every row from the right table. So instead of doing a full outer join or left outer join, instead we do a right outer join. So then in that case, we only want everything from the right table and the matches from the left table. But if there's no match on that left table, which is customers, then we don't want those records there. And clearly, as you can see here, is that left tables that had the nulls is no longer here. Instead, it's all the matching records from the left and right table, and then only that and everything is included from the right table, including April, who had no match on that left table. And now we're gonna move on to self joins, which is by far the most confusing join. And it takes a little bit of time to get used to, so don't feel overwhelmed if you don't get it right now. But the basic syntax of it is you're going to select just like before, and you just select the rows that you want and the columns that you want. So first, we're just going to take a look at that table so then we know what exactly is going on. So here you can see that everybody has a customer ID going from 1 to 10. And also with the associated customer IDs, everybody has a friend number. And that friend number is a customer ID number of another person. So you could see here that Barbara's customer ID is 1 and her friend is customer ID 10. And if you go scroll down to 10, so that means Barbara's friend is Clemmy. So that should mean that Clemmy's friend is also Barbara, right? And that's exactly how it goes. Here you can see that friend is equal to 1, and that 1 refers to the customer ID of Barbara. So what you're going to do here is we want the first name, customer ID, and friend from the table. But what we're going to do is we're going to split our own, like we're just going to split this table basically by itself. And we're going to do that by calling from the table name, and then we're just going to label it as something else that's not customer. So I just did A. So for customer is going to be A, and then there's going to be customers as B. So we want the first name from A, customer ID from A, friend as A, and we want B, first name, points, and friend. Actually, customer ID. And what we want to join it on is where the customer ID equals a friend. So basically what this query is going to do is going to tell us who's friends with who. So you could clearly see here that Barbara's customer ID is 1 and her friend is 10. And Clemmy's first name, Clemmie's customer ID is 10 and her friend is 1. So that corresponds to each other, where that customer ID from A is equal to the friend from table B. And of course, I know that this is really confusing right now, but with large amounts of data, and when you see like that, when you see two columns sharing similar values, that's when you use a self join, because you basically join the table on itself on a specified column. So say for example, we want to compare the cities of the friends, right? We don't have to include all of these, so long as that we have this on where the customer ID is going to match a friend. And instead, we're just going to want a.first name, a.city. And once again, you're getting the 2 pairs of friends, but instead we're getting what city they're from. So like Barbara's from Waltham, while Clemmy is from Sacramento. Amber's from Orlando, while Eileen is from Nashville. And so, yeah, that's the basic syntax of a self join. You basically just join a table on itself. And what you have to have in order to do a self join is that you need to have a column that's similar across the two. You have to have values in a column that's similar across the table. So, like we had before, that there's a customer ID going from 1 through 10, and there's a friend going through 1 through 10. And yeah, so that's about it for today's demo. I'm just going to stop sharing.
Thank you, Jay. That was really awesome. So yeah, that brings us to the end of our workshop. I hope this was super helpful, and I hope you guys learned a lot about SQL. Next week, we'll have an advanced version of the SQL workshop, and it's going to be on a Tuesday this time. And yeah, I'm just going to stop recording.